The vaccines developed against SARS-CoV-2, the virus that causes COVID-19, implements new technology that, though new and exciting, isn't uncharted territory. Early steps towards generating mRNA vaccines have been ongoing not since 2019, but for actually 30 years. Research for mRNA as a platform for vaccine development has been ongoing and tested for safety for years already. That's because it's been studied as a method to create or improve vaccines for diseases like Zika virus, HIV, and influenza, because the process to create mRNA vaccines would be quicker than traditional vaccines. So contrary to what many people fear, the coronavirus mRNA vaccine was developed quickly by design, not because of haste, and has gone through all the standard amount of safety testing. So how does this COVID vaccine work? Let's start with a quick review of how we know the virus infects a healthy cell. Each SARS-CoV-2 virus particle is surrounded by spike proteins on the outside and contains RNA, a form of genetic code that has all the instructions for how this virus needs to replicate. Once the virus enters your body, its exterior spike proteins bind to a specific type of receptor on the cell, allowing the virus to enter. The virus then releases its RNA into the cell. The cell has its own replication machinery, like a ribosome, for normally making its own RNA into protein. But now, the virus can hijack the cell's ribosome and turn its own viral RNA into protein that makes up the components necessary for a new virus. The process continues with more virus particles going on to infect other cells. Our body's immune response is what recognizes infection and fights it off. Vaccines are a way to give our immune response a huge advantage, a specialized instruction for exactly how to fight off a specific kind of virus before our immune response ever encounters the real deal. When your body receives a vaccine against a virus, it's like giving your immune system the opportunity to practice playing a video game with a super easy training level and learn exactly what specialized attacks are useful to defeating the game. Traditional vaccines, like the ones used against measles, give our body a harmless yet recognizable version of the virus, providing the opportunity for our body to learn how to best fight off this type of infection. This is called a live attenuated vaccine. Your immune system will not only win this training level, but it will remember how to win and gain the advantage against future infections of this virus. The mRNA vaccine mechanism is similar, except instead of giving your immune system a live attenuated virus, you provide just a recognizable small piece of the virus. As just a small piece of the virus, it can't actually cause any infection. The mRNA that's in the COVID mRNA vaccines is the message form of the RNA that encodes just the spike protein, without the rest of the virus. The message goes to the protein-making machinery in our own cells, where they create the spike proteins. mRNA self-destructs while the spike proteins go on to be used in that training level. In that training level, the immune system learns to make antibodies that latch on to the spike proteins and mark the virus for destruction. This gives the immune system the preparedness to prevent against a real infection in the future. This is a clever concept that has been previously limited not by safety concerns, but by the ability to keep the mRNA from being broken down once injected into the body, since mRNA is very fragile. But for the coronavirus vaccine, researchers figured out that enclosing it in a special oily capsule can protect it from falling apart before our cells get a chance to use it for immune system training. It's very promising that the vaccines are 95% efficient in preventing symptomatic infections, but we don't know that it prevents COVID transmission yet. That is, it's possible that you could have the virus in you, and And while your vaccination provides the immune response to protect yourself from experiencing symptoms, you could still transmit the virus to others. More research on that is required, but until that's completely ruled out, the familiar precautions should be taken to protect others: mask wearing, social distancing, frequent hand washing. Additionally, the immune response after vaccination takes time. Even if you're vaccinated with the first dose, you need to wait a few weeks to get the second dose, and then it isn't until a few weeks after the second dose that you get full protection. Things will gradually return to normal, but it'll be a dimmer switch that we turn up, not an on-off switch. So the precautions that we've been taking must continue. But with vaccination efforts, we can have an exciting prospect of a gradual return towards normalcy.